So I'm using beginning band as an example because that's where most of my experience was from. So let's pretend that our goal is to get students more comfortable playing the first 6 notes of their B-flat concert scale. And we're going to use Twinkle Twinkle Little Star as an example. So on my web page here, I can add a link to what that would sound like from their method book. This is from Sound.
Twinkling Stars.
So if students forgot their method book and didn't bring it home to practice, if they have a device and an internet somewhere, they can follow along and practice and hear what that sounds like on there. Raise your hand if you've tried Note Flight. Raise your hand if you have not ever used Note Flight before. Great, you're going to be my volunteers. So and I've done this before with my beginning band students where we used it on the smartboard and had them come up, but we're going to try to arrange Twinkle Twinkle Little Star using the first 6 notes of our B-flat concert scale with Note Flight. So we've got the first couple of notes here. Let's say that I'm a clarinet player here. Does that sound like? No, I'm not a clarinet player. All right, so who would like to volunteer to come up? Somebody who's never used Note Flight before. Kristen, I saw your hand. Would you like to be the first? Come on down. Woo!
You're next on the Price is Right.
Would you like to try to come up with next measure of that? The good thing about Note Flight here while she's working is that students can see the music, students can hear the music, students can interact with it and manipulate the notes as it's going along. All right, then we can check. Kristen, let's check your work. So, start here at the beginning.
Nice.
Volunteered to go first. Pick the next person. Is there somebody who's not used Note Flight before that wants to give it a whirl? And then I saw Aaron's hand. So Aaron, you want to try the next measure? The cursor around.
This is a tough
I
one.
believe in you, buddy.
What else is this getting Dakota to do? Audiate, using some sounds as symbol, listening to it first, and then trying to figure out what this is. Okay, Aaron, come on down. And try the last measure. Cursor, where would you like it to go? If you make a mistake, you could go and fix it. We can go back and listen to it, make sure it's right. So instead of having students just learn how to play that out of their method book, we made a class arrangement of it. We got the students to create. We could do this as a class or we could do that individually. But I gave students parameters. I'm not just going to say, go create something. We gave them, you have your first 6 notes to work with, gave them the starting pitches. Let's think of some other things here that we could do to create if students maybe were having more trouble with notation. So this website is called Figure Notes. There's a lot of research out there these days on color notation. I'm not super familiar with all of that, except that it exists, and I would like to look more into it. But especially, I've learned for students that have dyslexia, using color notation is a really great way to help them learn to read music. So there's some examples down here. Twinkle Twinkle happens to be one of the examples. Aaron, since you were the last volunteer, choose somebody to come up and let's see if we can try a little bit. So here's our notation down here, and we're going to try to use the keyboard here to play Twinkle Twinkle Little Star. This is the notation for it. So maybe this would be a good introduction to standard notation. Yeah, choose somebody. We've got lots of volunteers I can see by their enthusiastic hand raising and faces, and they look ready to go. You could have students just kind of play around on the piano here too, but so that's what you're reading from.
Do I just play the whole thing?
Well, you can just try it up first. So this is also a good way maybe to students to look at concepts of intervals and space, and we could maybe take this and then go to traditional notation as a gateway or as a step. There's also, let's see, this color piano. Everybody's seen this, so you can. Well, let me just play. Let's do this. Like those old player pianos. Also come over here, and I could slow it down. It's at 33. If I wanted to look at it a little bit more closely, there is a whole library of things that you could find and look at. Let's see, what else could we do here? I could, You could also play, and as you're holding down the cursor, it shows you how long the duration is. So there's an option for students who might need a different way of exploring with music and creating and using technology to figure. Notation is hard. If students have trouble with reading in general, then reading music is even going to be harder than that. So that is something that you'll want to keep an eye out for with your students.
Is there a way on this to like flip the keyboard so that you can see the notes coming and then play it, or does it only show like what you want to play?
I haven't seen that in this particular app, but that might be something that would be interesting to look at. I'm not sure. We'll play around with it a little bit more, but I just wanted to show you that example. That would be a good idea, though. Let's see, what else? And finally, has anybody used Incredibox?
Yes.
Okay. Now, in Universal Design for Learning, the third principle is motivation. So first, we have to get students on board with what we're doing, and we might need to get a little creative when doing that. I don't know about this naked guy here. Let's get him some clothes on. So, as I'm showing you some examples of what's going on, be thinking about how could you apply this in an instrumental music setting. The goal is not the technology. The technology is the tool to help reinforce the goals and objectives that you already have for your students. The goal is not to get them to do this. The goal is to use this to get them to do the music that you have in mind. So let's get them dressed here. This hat's fun.
That's fun.
I could pause one. I could isolate the little guy so I don't see what he's doing by himself. Okay. So could you think about ways that you could use that as a tool to motivate students and get them encouraged? Rhythm. You could get students to try to play with what their guy is doing. Improvise over the top of it. Oh, I should have gotten all the guys out there saying just like So, let's see what we have next here in store. So let's say, okay, let's go back to this. You've got your arrangement. The students have arranged their piece. They can perform it on their instruments. So perform is the next thing. We've got them to create, perform. We're going to do a little bit of singing here. So this is Soundation, which I think is very similar to GarageBand, but not all devices come standard with GarageBand. So Soundation is something that is free and online and open platform, so no matter what device you have. So I'm gonna, I have a little bit of, what's my accompaniment sound like here? All right, so we're gonna do a let's see, I think this is our starting pitch for Twinkle Twinkle Little Star. We're going to sing our class performance of it with our accompaniment. Are we ready? All right. Okay. Shall we? Yes. 1, 2, ready. Twinkle, twinkle, little star, how I wonder what you are. In an instrumental setting, we could use their instruments to do that. My middle school students loved using GarageBand to record themselves playing because they love to listen to themselves anyway. But when they could add accompaniment to their recording, they thought that sounded awesome. And they would come up with some super creative things as presents for their families at the end of the semester. We would make, this was back when CDs were around, we would burn a CD of their GarageBand recording and give it as presents to their friends and family because they thought that they sounded so awesome. We've got our creation, we've got our performing. Let's see, what else do we do to perform using technology? This is called solfeggio, and this is not related to Twinkle Twinkle Little Star, but I just wanted to share with you that this is a different way to get students to perform using technology. So.
I thought that I'd been here before.
You can mute it so that you can play the lyrics or sing them.
Words could be broken tonight. Back to life. Got a feeling that I'm going under, but I know that I'll make it out alive. If I quit calling you my lover, move on. You watch me live till I can't breathe.
What is that?
That's solfeggio. Lots of different options here. So think about ways that maybe you can use that in an instrumental setting. We've got to keep on scooching. So we've performed. Now the respond, one thing that you can do, if I go back to my website here, you could use this EduBlogs as a way to communicate. So let's say, oh, I forgot to show you. Let's say I've got my final performance done. So here's my finished Twinkle Twinkle assignment. The acoustic version. It's not singing on that one. That was clear enough. That was a little bit better. So we've got that on there. You could respond. There's a little comment box where you could get students to write about what they heard or what they did, which would be an option. Also, there's a lot of research out there on using games as a way of assessment, because if we are playing games, then we're having fun and also getting to determine whether or not you are able to do the concepts that are going along with it. So this website, musictechteacher.com, is pretty awesome, and it has lots of different things. Let's say our main goal was getting students to learn the first 6 pitches of their B-flat concert scale. So we're learning about note names. Let's see. Oh, it's basketball season. Let's do some basketball. What? No.
All you have to do is put that and run it.
Okay. This also, this works really good with a smartboard where students can come up and be interactive with the smartboard here. Let's see. Okay, who would like to go first? If you get the question right, you get to try to shoot a basket. Come on! Click on the answer that you think is right. Okay, now you have to sit around, you move your little guy around with your cursor and see if you can shoot it. Yeah, click. And then you have to line the circle. What is this? No results found. Oh, try again.
Nope.
That was
Let's try it. Thank you, Nick. Who's next?
Oh, I'll go again.
I don't know.
Janet, Ben.
I think I did it in Mexico.
It's your birthday.
Happy birthday!
Why didn't we know this?
I texted the group this morning.
Yeah, we have to play Happy Birthday.
Soulfest.
Happy birthday to you.
Soulfest though.
Happy birthday. Alright. Nice. Okay. Yeah,
That's
No, no results.
That wasn't me.
All right, so just an example of things that could be pretty motivating, and also follow along with what your plan is, so I can assess students' knowledge of what is going on there. So we created, we performed, we responded, mostly using things that are free and online, and you just need a device. Okay. Very good. Yes, mean is one. And do you remember, Carmela, what does a mean tell us?
Is that like the average?
Mm-hmm. So the mean is the average of your data set. What's another measure? There's three of them we talked about last week. So mean is one.
Mode.
Lana, what's another measure of central tendency?
Mode?
Mode. Very good. And do you remember, what does a mode tell us?
The most frequent value.
The value that's most frequently portrayed in the data set. Very good. Excellent.
Thank
All
you.
right, there's one left. I've got Emily. Emily, can you tell us the third measure of central tendency? This is a little unfair because you weren't here last week.
Is it median?
It is median. Woohoo! You get double bonus points for not being here last week and knowing that. Can you tell us, what does the median tell us?
It's the very middle of the data set.
Mm-hmm. So if you were to organize all of the numbers in your data set from smallest all the way to biggest and take exactly the middle number, that would be your median. Very good. All right, excellent job so far, everybody. All right, so the measures of central tendency are going to tell us what's the same about the data set. So your mean, your median, your mode, how the data is similar to each other, versus measures of dispersion. So we had three measures of dispersion that we talked about last week. So I'm going to draw a name out of the bag. If you can tell me one of the measures of dispersion that we talked about last week. Michelle.
Oh gosh, I may botch this, but is that like the standard deviation?
Standard deviation, excellent. That's one of the measures of dispersion. So what does standard deviation tell us about a data set?
I guess it's like how far apart, like in a numerical value, like 2 points are from each other.
Yeah, so from the mean or from the average, excellent. So it tells us how spread apart, how far apart the data is from the mean. So the mean tells us the average of the data set, and the standard deviation tells us how spread apart numbers are typically from the mean. Usually when you are doing very basic descriptive statistics, you'll see the mean and the standard deviation most commonly reported, the average, and how far apart scores generally are from the average. Michelle, do you remember, what does it mean if we have a small standard deviation versus a larger standard deviation?
A smaller standard deviation, would that be like if you're looking at like the age of a population of like your group, for example, that'd be that most of the people are closer in age versus there's like a greater variety?
Yeah, so if I were to do a study of just looking at sixth graders, just sixth grade students, then the standard deviation would probably be pretty small because most students are probably going to be grouped around like 12-ish years old without a lot of variation. Versus if I were to do a study of a wider set of population, if the ages ranged from 0 to 90, maybe the standard deviation would be more spread depending on what we're talking about because there's more variety in the numbers that we have. Good. So standard deviation is a measure of dispersion. Michelle, you're off the hook for a second. Who can tell us another measure of dispersion that we talked about last week? And that someone is Shukai. Yes, the IQR. Tell me more. Yes, so you're talking about percentiles, which is a measure of dispersion, or the IQR is the interquartile range. So percentiles are a measure of position that shows where a value stands relative to others. And the interquartile range measures the spread of the middle 50% of your data. So this is useful because the 50% of your data is less affected by outliers than other measures like the total range. So, I just gave away what would be the next answer for something. So hopefully, maybe if you're listening, you caught it. But yes, interquartile range or percentile. Good, Shukai. Woohoo! All right. Maybe you caught it. I accidentally said it. What is the third measure of dispersion that we talked about last week? We have standard deviation, we have percentiles, and Nicole, we have
Range.
range. Excellent. Good. Can you tell me what the range is, how it's calculated, and what it tells us?
The distance between the highest and lowest values.
Yes, so the range tells us the distance between the highest and lowest values. So measures of central tendency tells us how similar the data is. Measures of dispersion tells us how different the numbers in a data set are. And both are useful in describing and providing descriptive statistics for the data set that we have. Now, whether you use mean versus median or mode depends on your data set and what you're looking at. Similarly, with measures of dispersion, whether you're talking about percentiles or interquartile range, or standard deviation, depends on what's happening in your data set and can be very heavily influenced by outliers. So we want to keep that in mind when looking at those scores. So, excellent. Descriptive statistics. Simplify, summarize, organize a large amount of numerical data and can focus on describing visible characteristics of a data set. We talked about measures of central tendency, measures of dispersion, and in descriptive statistics, we're not doing any kind of experiment. We're not manipulating any variable. We're not doing any changing as the researcher. We are merely just saying what is there, what has happened. So we're just describing the sample's personal characteristics. We can also use descriptive statistics really in any kind of research when we're talking about the demographic characteristics of the data set that you have. So I'll show you an example that I put in a safe place over here. Matthew's back. Matthew's back and better than ever. All right, so this is an example of a distribution of different demographic features that I created for a project that I recently completed. So we have the actual number of people in each category, and then in parentheses is the percentage of people that were scored there. And then if you look and see in all of the columns, I've reported the mean is the big M, and the SD is the standard deviation. So if I'm looking at the first column, the women who responded to the study, there was 357 women total who responded to the survey overall, or 76.8% of the overall population of people that responded. And then when they answered questions about depression, 326 of the overall total women responded to these questions. And then we've got the mean, the standard deviation, going down here for the columns of the degree of severity of depression. So we can use descriptive statistics to do a quick glimpse of what would otherwise be a whole lot of data. So you would not, in this report, you would not want to see the scores for all 326 women who responded to the depression survey. That would be silly. Nobody would have time to do that. And what would you get out of that? So if we can put it all in sort of a table or descriptive statistics, and we're summarizing all of that mountain of data into numbers that we can understand a little bit more easily to show what's the same and what's the different about the sets that we have, then that's a lot more helpful in giving the reader a snapshot of what's happened with the data. Okie dokie. So descriptive statistics are describing our data. Now, ex post facto and experimental designs are going to look at differences between groups of data sets. So descriptive statistics, we're just reporting what's there, we're describing it, we're summarizing the data. But when we start to do experimental designs, we're seeing what is different about the groups of data that we have. In ex post facto designs, there's an independent variable and a dependent variable. So the independent variable is also called the predictor. So in ex post facto studies, the independent variable is pre-existing. It's fixed. The researcher did not do anything to change that variable. The dependent variable is something that you as the researcher are studying to see if it changes based on what is happening with the independent variable. So for example, I gave the example of the independent variable in this scenario is a parent's history of depression. So that's fixed. That's the independent variable. I'm looking to see what that, but I'm not changing a parent's history of depression. I'm not, as the researcher, going in and making somebody depressed. Hope that would be very bad, and IRB would never approve that. So that's a very unethical study, and I don't recommend that. So that's something that's already there. And then what I'm studying, the dependent variable, is the child's mental health. I'm not manipulating the independent variable itself, but I'm seeing if a child's mental health is dependent on or is somehow caused or shaped by the parent's history of depression. In experimental research, we have an independent variable, the predictor, and we have the dependent variable or the outcome. But in this case, the researcher is controlling the independent variable. So if I, let's say, wanted to study plant growth, and I need to study this a lot because anything green that comes into my house or outside of my house just dies a very horrible death. But so I need to get better at that. I'm good at keeping the human beings in my house alive, but not the green plants. So please help me, send help. So I want to find out more about plant growth. So I, as the researcher, might manipulate the amount of exposure to sunlight the plant gets. And in some cases, some plants do better with more sunlight. Some plants do better with less sunlight. So the amount of sunlight I'm exposing the plant to is the independent variable. And what I'm studying, the dependent variable, the outcome, is the growth. In both designs, we want to see if a causal relationship exists between the independent and the dependent variables. Does one cause the other to happen? As opposed to what is the kind of, what is the word that we use when we're looking for a relationship where it is not cause and effect? A correlation, good, Liana. So a correlation, not cause and effect. We're just seeing if there is a relationship, if those two variables are related. But in an experimental design, we are trying to determine if one variable causes another to happen. All right, how are we doing? Any questions?
Is it always true that in ex post facto, the independent cannot change? It's like it's fixed. I guess. The independent variable is not manipulated by the researcher. It is fixed. So if I wanted to do a study on, maybe I'm comparing height and IQ. I want to see if maybe my dependent variable is IQ and the independent variable is somebody's height. Now that would be silly. So, but maybe the independent variable, I can't change your height. It's fixed. I can't make somebody taller or shorter. So that is what it is. But I want to see if height has anything to do with somebody's IQ. And that's also nonsense. And that would probably not get approved by IRB. So don't do that. The experimental design, you as the researcher are manipulating the independent variable.